All right, next topic for you guys in National 5 is simultaneous equations, right? It's a big topic, it's quite an important topic, and it's pretty self-explanatory from the title nonetheless, okay? But I'll take you through this in detail. This is the kind of video you might want to watch a couple of times to get to grips with simultaneous equations in this first instance, at least anyway. Okay, so we often see an equation like this, and as I've said here, on first glance, it doesn't seem like anything different to what you're used to. It's an equation, and generally with equations we solve them. But unfortunately with this one, as it is at least, and with kind of the information that we've got, we can't solve it. And the reason we can't solve it is basically because there's two variables, okay? So if you look there, what I mean by variables is just is the letters or symbols. Obviously we use letters as symbols, but as I say, with the information that we've got, in other words, just the equation itself, and not knowing what x or y is, we cannot solve it. If we're trying to solve it, we're trying to find out what x and y are, and every x and y actually are. And every equation that you've ever dealt with up until this point has only had one or the other. It's only ever had one variable, and you've been able to solve it because of that. But as soon as you have two variables, whether it's x and y or a and b, or m and n, whatever it is, okay, as soon as you've got those two variables, you can't solve it by itself. Okay, the reason being there are actually infinite solutions. Okay, and I'm just going to take you through three of them just now and just show you what I mean by that. So the actual equation as it's written is 3 times by x minus 2 times by y equals 12. And what it basically means is 3 times by something minus 2 times by something else will equal 12. So I've just picked some random numbers here. Okay, and we can see that 3 times by 10, which is 30, minus 2 times by 9, which is 18. Okay, so 30 minus 18, that is equal to 12. So one solution could be that x is 10 and y is 9. Okay, that seems like a perfectly good solution, and that is a solution. But the point is there's other solutions as well. We can see that 3 times by 1,000, okay, and I've chosen 1,000 just because it's a nice big number. But 3 times by 1,000, which is 3,000, minus 2 times by 1,494, which is 2,988, okay, take them away from each other and you get 12. Okay, so another solution could be that x is 1,000 and y is 1,494. Okay, a third solution, okay, we could say that x is minus 8 and y is minus 18. 3 times by minus 8 is minus 24. 2 times by minus 18 is minus 36. Minus 24 minus 36 is positive 12, and that's another solution. The point is this can go on forever. Okay, x equal to 1 could be a solution, and then we could work out what y is. X equal to 2 could be a solution, and then we could work out what y is, and that's the point. But what we are generally looking for when we're dealing with equations is one specific solution. I don't want to know every single solution because there are infinite ones. I'll be here forever writing them all down. Okay, so these are just a few of the possible solutions, but we do want to find one specific solution. And the way that we're going to do that, if we don't already know one of the values, is to solve them simultaneously. Right, there's 3 different ways of solving simultaneously. I'm going to show you one just now. There's 2 more to come, and there's when you're asked to do this, when you have the kind of the situation whereby you have 2 equations and you want to solve them to find one solution, you only ever have to do one of these methods. You don't have to do all 3 of them, and one of them is going to be easier than the others. Okay, but I'm going to start you off with this first one, which is solving it graphically. Okay. Right, what we mean by solving graphically is literally drawing a graph. Okay, when we have simultaneous equations, I mean, as I said earlier, the clue's in the name. It means solve at the same time. So what's actually going to happen here is you're going to have 2 equations. Okay, you're going to have 2 different equations that solve at the same time, and you're going to kind of combine them in some way. As I say, there's 3 ways of doing this to actually find the one solution for both of them. Right, this first method, unfortunately, is quite long, is quite tedious, and we're not going to use it that often, but it is important nonetheless because we can still, we still might be asked the question, and we might think we have to solve it graphically, but it doesn't need to be solved that way. But we can think about what it means for a graphical solution. Okay, so we're going to have to draw these 2 graphs out in this first instance. We're not going to spend ages doing this, don't worry. And the point is, these are equations of straight lines. If you actually look at these equations, and these are 2 slightly different ones, but they are equations of straight lines. Okay, so somewhere there is a straight line that refers to each of these equations, and they look quite similar. We've got 2x plus y equals 6 and x plus 2y equals 6, but they are very, very, very different. Okay, right. First things first, I know that they're straight lines because I have an x and a y, and because there's no x squared or y squared or anything like that. They're both to the power of 1 and no more. So you can always spot an equation of a straight line when there's an x and a y, and it's just to the power of 1. It might just be x equals, it might just be y equals, they might not actually be both of them, but that's something in itself. If you remember, that's either a horizontal or a vertical line. Okay, but these are straight lines. They're going to be at a slight angle. They're going to have a gradient. They're going to cross the y-axis at some point. But the point is they are equations of a straight line. These two are given to us in this form, okay? In other words, the x and the y are on the left-hand side. But if you remember straight lines, generally they're y equals, and you can see this one would just be rearranged and be y equals 6 minus 2x, or more importantly, y equals minus 2x plus 6. And then it's more of the form that you're used to. It doesn't matter what form it's in. And the point is, if it's in a different form, you can change it to the form that most suits the method that you're trying to use. So for this one as well, okay, it'd be 2y equals minus x plus 6. And then we could divide by 2. But the point is, they're just in this form, and we're going to use this form regardless. In other circumstances and other methods, it might be easier to change it into a different form, but we'll cross that bridge when we come to it. Okay. Right. If we're going to draw the graphs of these, we need coordinates. Okay. We need coordinates to be able to plot onto a set of axes, and we need to join them together to make a straight line. If we're going to find coordinates, we have infinite options, and that is the whole point. Okay. The solution to any one of these, okay, is just a point that's on the line. You're going to see that more and more with the next couple of slides. All right, so using those same equations again, the point is straight lines, as I say, go on forever and ever and ever. Okay, when we draw them, we only draw a part of it, but if we kept on extending it in the same direction, it would go on forever and ever and ever. There would be infinite coordinates on there, and then hence there would be infinite solutions to any one of these equations. But as it's a straight line, we only actually need to find 2 of these points. Imagine if you've drawn a straight line. If you have 2 points, if you connect those 2 points, you have a straight line. You don't need to find every single one of these points, every single one of the points on that line. You just need to find 2 of them, and then you can join them up, and you can extend that line as far as you need. That's another important thing to realize. It's not just the line that's between those 2 points. It goes on in either direction forever and ever and ever. But as long as you have 2 points, you have a straight line. Okay? This still just shows us all the possible solutions to that equation. So we've still not actually got a solution to these 2 equations at the same time. But you'll see what happens when we actually draw these out, how we're going to actually find the solution to them both. Okay? Because if we repeat the process of both of them, you're going to find one solution that works for them both. Okay? And just bear with me whilst we go through this example. You'll see exactly what I mean. Right. So this is the question, sorry. We're going to solve these graphically. 2x plus y equals 6 and x plus 2y equals 6. Right? This one specifically says solve graphically. Okay, it might just say solve, in which case you have the choice of the 3 methods. We don't actually know any methods just now, so I'm just going to stick specifically with graphically, and we are going to draw these 2 lines, and we're going to solve them that way. Okay. So what we want is a set of axes like this, okay? And then what we want is we want to find some points, right? We used to do this, okay? And you did this in second year. You'd actually construct a wee table, okay? Something that looks like this, okay? You'd have an X on one row and a Y on the other row, and then you'd have a bunch of numbers, right? I've picked 0, 1, 2, and 3 because they're nice, easy numbers. The point is you could pick any numbers you want. What's going to happen is you're basically going to take these numbers, and these are just our X values, and you're going to put it into the equation, and then you can find out what y equals. Okay, so to find what y equals, all we do is substitute different x values into the equation. So I'm going to start with that first one, 2x plus y equals 6. Okay, and I'm going to substitute in different values of x. So I'm going to take my x out, and I'm going to substitute first of all 0. So it's going to be 2 times by 0 plus y equals 6. Now, because there's only one variable now, because I've just got numbers and one letter, I can solve this. Okay, and this is part of the difficulty with simultaneous equations. As that is, I can't solve it. As soon as I replace one of the letters with a number, I can solve it. But what it does is just gives me one possible solution. Okay, but let's just go through it and see what happens. 2 times 0 is just 0, plus the y equals 6. Okay, 0 is just obsolete, so it's just y equals 6. But the point is this gives me a point on my line. It gives me the point 0, 6. Okay, and I can plot that on my set of axes, and it's there. So 1 point alone doesn't give me anything. There could be a straight line there, could be a straight line there, could be a straight line there, could be anywhere. But if I have that second point, I can join them up, and I can find the actual straight line. I can draw the straight line. Okay, so I'm going to do the same again. I'm going to use when x equals 1. I'm going to substitute into the same equation. So I've got the same equation. So it's going to be 2 times by 1 now, plus whatever y is going to equal 6. And I can solve this. 2 times by 1 is just 2. So 2 plus y equals 6, in which case y must equal 4. Okay, so now when x is 1, y is 4, and now I have another point, 1, 4. Right, I'm going to continue this just to show you what we did before, but the point is I could join these up, and I could extend it, and I could have my straight line, and it just goes there. But I'm just going to keep going. I'm going to show you the other points. So when x is 3, no, it should be when x is 2, sorry, I've just not changed that. When x is 2, it's going to be equal to 2 times by 2. I've completely mucked this up. Okay, I think I've just done it in a different order. There you go, it's just the other order. So when x is 2, 2 times 2 plus y equals 6. So we get 4 plus y equals 6, in which case y is 2. That's that point there. Okay, so I have the point 2, 2, which is there, and then I have this point here. When x is 3, okay, then y works out as 6. So that gives me the point 3. Y works out as 0, so it gives me the point 3, 0, which is down here. Okay, so I could have found all of them. I could find 7 more. Okay, I could find all of the points on the line, but it would just take me forever because there are infinite points. Now what I have is I have the points, and you can see that they all line up to make a straight line. So all I need to do is join it. But as I said, you could have done that with any 2 of those points. Okay, it doesn't matter which 2 points you choose, but I could have done it with any 2 points, and I just extend it beyond those 2 points. Okay, right. But what I want you to do going forward is use the points on the axis. Right, further forward, further into different topics, they're the most common points that we use. We use the points on the axis. Okay, so this point here and this point here. If we find them, then we can join them up. And the point is they're easier to use because at these points, some value equals 0. And this is one thing you've got to get your head around. Okay, so at this point on the y-axis, x equals 0, and on the x-axis, y equals 0. Okay, but nonetheless, what you're going to do is you're going to take your equation and you're going to replace the x with 0, work out what y is, and then replace the y with 0, and work out what x is, giving you 2 separate points that you can plot and join up. Okay, so I'm going to use the second equation. So x plus 2y equals 6, and I'm going to do exactly that. When x is 0, I have 0 plus 2y equal to 6, in which case 2y equals 6, in which case y equals 3. This gives me the point 0, 3, which I can plot on my set of axes. And I'm going to plot it on the same set of axes because I am trying to solve these graphs simultaneously, solve these equations simultaneously. So then I do the same thing with y equal to 0. Okay, so substituting that in, I have x plus 2 of my zeros equals 6. 2 zeros is just 0. X plus 0 equals 6, so x equals 6, okay, which gives me another point. So when y is 0, x is 6, and then any coordinate is obviously just x and then y, 6 and then 0. Just like over here, it was then x and then y, 0 and then 3. So that's 6, 0 there. And once I've got those 2 points, once again, I can join them up and I can form a straight line. Right, this is hopefully clicked for some of you what our overall solution is, because what we've got now here is we have a point where they meet. And at the end of the day, what we're trying to do here is we're trying to solve these simultaneously. We're trying to find one solution that basically satisfies both of these equations. Okay, so what we're looking for when we're doing this graphically is we're trying to find a point of intersection. Okay, and that will be our one common solution. So in this case, that's that point there. And then it's not just a case of just pointing it out and we're pointing to it. It is actually numerical values that we're looking for. So in this case, we have a point 2, 2, or in other words, x is 2 and y is 2. And the point is that is the one solution that satisfies both of those equations. Okay, it satisfies them both simultaneously, and that's what we're looking for here. We're looking for one solution to both of these. Right, this obviously was a long and tedious method of doing this. There are better ways of doing this, but I want to show you this first. Quite often we're actually asked to find the point of intersection of 2 lines. Okay, and you could do it graphically. You could draw it out like this. I'm going to show you methods later on that make it easier, but that's what we're trying to find. We're trying to find basically the point where they intersect. We're trying to find the one value that basically satisfies both of those equations. And you can look at this. Okay, if you take these values and put them back in, if x was 2, that would be 2 times by 2, which is 4, plus 2, which is equal to 6. Okay, and then with the same values, we get the same answer. X is 2, plus 2 of my 2's is 4. 2 plus 4 is also 6. Okay, so it's the one solution that satisfies both of them. Right, so one more example for you. So another 2 equations, and we're going to solve these graphically as well. We're going to do exactly the same, but we're going to try and speed up the process a little bit and just find the points on the axes. So I'm going to take that first equation, x minus 2y equals 2, and I'm going to find where it crosses the y-axis. So it crosses the y-axis when x is 0. Doesn't necessarily matter, but just be careful with your points. So when x is 0, if I substitute that in here, I get 0 minus 2y equals 2. I can solve this. Minus 2y is equal to 2. If I divide both sides by minus 2 to find out what y is, then y will equal minus 1. 2 divided by minus 2 is minus 1. And this gives me my point. When x is 0, y is -1. It gives me the point 0, -1, which I can plot on my set of axes. So 0 in terms of where it is along the x-axis, and then down to -1. Okay, and then I'm going to do the same thing. I'm going to find where it crosses the y-axis. So when y equals 0, this is where it crosses the x-axis. When y equals 0, x minus 2 times 0 equals 2. Okay, so I'm plugging it into this first equation again. I'm changing my y for 0, so it's x minus 2 times by 0 is equal to 2. 2 times by 0 is just 0, so it's x minus 0 is equal to 2, in which case x is just 2. So this gives me another point. When x is 2, y is 0, so it gives me the point 2, 0. And the point 2, 0 is there. As long as I've got 2 points, I have a line. I can join them up, okay? Right, so that shows me all the solutions to that equation. I've got a solution here. The line's not perfect, but there is a solution there, there's a solution there, there's a solution there, there's actually a solution here, there's a solution here as well, and there will be many, 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 infinitely more, okay? But I want one that satisfies both of these equations, so I'm going to do that same process again with this equation, and I'm going to basically find where these two lines join, okay? So now I'm dealing with x plus 2y equals 6, and I'm just going to do the same thing. When x is 0, I substitute in here, so I get 0 plus 2y equals 6. 0 plus 2y is just 2y, and it's still equal to 6, in which case y equals 3. It gives me another point, 0, 3, but this is a different line. I'm going to use a different colored dot this time, 0, 3. I'm going to do the same thing again to find out where it crosses the x-axis. It crosses the x-axis when y equals 0, so that's what I'm going to substitute in first of all. So x plus 2 times by my 0 is equal to 6. 2 times by 0 is just 0. So x plus 0 is equal to 6, in which case x is equal to 6, giving me a coordinate of 6, 0, which I can plot over here, and I can join up to give me another line. And I can see, hopefully from this, that they meet at this point here, okay? And that is my one and only solution to both of these equations, okay? The one solution that satisfies both of those equations simultaneously. In other words, it's the point 41 when x is equal to 4 and y is equal to 1. Okay, a long process, okay, but we're not going to spend too long doing this. I just want you to kind of do a couple of examples here, and I'll try and speed it up in the next couple of methods. Okay, but write your answer in full. The whole idea is to try and find one solution that works for both of them. So x equals 4 and y is equal to 1 is the solution here. Right, I'm suggesting you use x is 0 and y is 0 to find your 2 points. You don't have to, but more often in the future, they're the points that we're going to use, okay, where it crosses the x-axis. I could have found other solutions here and just then drawn the lines, see where they meet. But these are the easiest ones to use. When we're using 0, you can see that it works quite easily anyway. I mentioned earlier in terms of actually rearranging these equations, or the fact that they could be rearranged to give you a different format. And if you write it in the form y equals mx plus c, okay, so y equals something. If you remember, the c part is the point where it crosses the y-axis. Okay, that's kind of why, yeah, this process is quite straightforward.